Let's begin section 1.2 by filling out our Cornell notes in the warm-up section. You should have problems A, B, and C. Now is also the time when you want to fill in the date and the section number, which again, 1.2, chapter 1, section 2. Let's fill in our objective. Learn to translate between algebraic expressions and word phrases. Next, complete the essential question. How do I write and identify equivalent expressions using fractions, decimals, and integers? We're going to start by thinking of some word phrases and expressions that we can use with addition, subtraction, multiplication, and division. So if we think about some key words for addition, we could say a number plus 5 as an example of a word phrase. Add 5 to a number. Sum of a number and 5. 5 more than a number, or a number increased by 5. Take a minute to fill in the red words on your Cornell notes in the addition keywords box. The matching expression to the word phrase is on the right. And you can see that expression, n, with the plus sign and 5, is the same for all of those word phrases. Let's think about subtraction. We could say a number minus 11, subtract 11 from a number, difference of a number and 11, 11 less than a number, and a number decreased by 11. Let's fill in the blue words in the subtraction keywords box. I want you to circle the term less than. If you take a close look, the expression is x minus 11, where the x is in front of the subtraction sign. 11 less than a number has 11 written first. This is a strong point of confusion for many students. When it says 11 less than a number, it means you're taking that many away from your starting value. So watch out for the term less than when you're trying to turn it into an algebraic expression. Keywords for multiplication. We have times, multiplied, product. Fill in the green words in the multiplication keyword box. The expression that matches is 3m. Get very used to seeing a number next to a variable, a coefficient with a variable, because we won't use a times sign of any kind when we have a variable involved. Some of the symbols we could use, the X, the dot, sometimes a star you might see on some electronic devices, or parentheses. Lastly, division, divided by, divided into, or quotient. Purple words go into the division box, or the pink words if you'd prefer. Pay attention again to the divided into, where the 7 is listed first. We would divide the number by 7. So a, if a was our value for our variable, a over 7 or a/7. Notice we don't have the division sign that you're used to with the line and the 2 dots. We're kind of going to get rid of that, leave that in elementary school, and we're mostly going to be using the fraction form, a over 7. So if you want to put an example of that in your notes, feel free. Let's move on and write an algebraic expression for each word phrase. In lesson 1.1, we talked about algebraic expressions, that they have a variable and a number and one of the operations at minimum. So 9 less than a number w. Watch out, less than, that's that key term we circled. That means that we are taking 9 away from w. So we would be careful to put w in front and subtract 9. Example B, 3 increased by the difference of p and 5. Lots of terms here, increased by. If we look at our keywords, that's the addition box. Difference is in the subtraction box. When it says difference of p and 5, that means p is subtracting 5 from it. So we would start by using the plus sign between the 3, and then the p minus 5 is in parentheses. Difference is the answer to a subtraction problem. So in order to make sure we find that answer first, we have to use parentheses so we follow order of operations. Now we need to write a word phrase for the algebraic expression 9 minus 3c. Take a look at your keyword boxes and choose some of the words that you prefer. If you break it down, you can see the multiplication piece of 3 times c. So one of the phrases you could use would be 9 minus the product of 3 and c. Write a word phrase for the algebraic expression 7 plus 19b. Again, when you break it apart, that's 19 multiplied by b. So a possible phrase could be 7 plus the product of 19 and b. You can see from all of the keywords that there are a lot of different ways we could write this. Just like the English language, there are many words that mean the same thing, so it can be very confusing in math. So it's important to understand what all the terms mean and which operation they refer to. In your notes, go ahead and take a minute or two to write the algebraic phrase in words in as many ways as you can. Using those keywords from the boxes, see what you can come up with for the phrase given below. Let's move on and take a look at a word problem. To solve a word problem, first interpret the action you need to perform and then choose the correct operation for that action. In other words, decide what you need to do and then complete it. A restaurant leased its banquet hall for a function. The cost was $10 per person. Write an algebraic expression to evaluate what the cost would be if 20, 21, 22, or 23 people attended the function. Combine n equal amounts of $10. So $10 times n will give us the total. Our total will be in dollars because we're computing a cost. And n represents the number of people. So if we put this in a table, it's easy to view. We have 20 people, so 10 times 20 is $200. 21 people, 10 times 21 is $210. 22 people, 10 times 22 is $220. 23 people, 10 times 23 is $230. A table gives you a nice way to view multiple sets of data at the same time. Let's look at our tasks. First, make sure your Cornell notes are filled out completely. Second, review your notes and complete the summary before class. Remember, the summary is answering the essential question, which was, how do I write and identify equivalent expressions using fractions, decimals, and integers? Third task, come prepared to take a formative, non-graded lesson quiz on how well you understood the material.